Hello and welcome to the FluCoMa podcast. Today I'm talking with Dr. Artemi-Maria Gioti, who is a composer and artistic researcher specializing in the field of artificial intelligence. So today we'll be learning more about her creative work, which has been performed all over the world, and also about her research. Artemi notably focuses on the idea of interactivity, viewing the musical work as the product of collaborative and distributed human-human and human-computer co-creativity. We'll also learn more about the ERC-funded MusAI project, of which Artemi is a team member, a research program which looks to investigate the cultural implications of AI, examined through a group of critical interdisciplinary studies examining AI's relationship with music. So, Artemi, hello, and thank you for talking with me today.
Thank you for the invitation, Jacob.
You're quite welcome. So perhaps you could begin by explaining how you got into the world of music and composition, the world of artistic research, and the field of artificial intelligence.
Great. So, I guess I started with a bachelor's in instrumental composition. So I studied in Thessaloniki at the University of Macedonia. And during an Erasmus semester in Vienna at the University of Music and Performing Arts, there I came in contact with electronic music and specifically live electronics. So after that, I decided to study computer music in Graz, which is also in Austria. And subsequently, I did an artistic research PhD in composition also in Graz. I guess that my PhD did have a focus on artificial intelligence, on machine learning, but I don't necessarily think of myself as a composer who specializes in AI or machine learning, even though I use machine learning in most of my pieces, because to me machine learning is essentially technology. So I'm really interested in technology, and I'm interested in the reciprocal relationship between composition and technology. So I'm interested in how technologies shape musical thinking and function as ideation tools.
Yeah, no, that's great. We'll be able to get into all of your thoughts on that subject as we go on. So you're saying much of your research focuses on interactivity, so this interaction between technology and humans. And in the program notes for some of your pieces, you use the term of interactive music system. So for bass clarinet, an interactive music system, for double bass, an interactive music system, etc. So I think it could be really useful to begin if perhaps you could break down this term and what it means for you in a theoretical sense, and also what an interactive music system is in your work in practice.
So I guess that I describe the works I have written over the last 6 or so years as interactive compositions. And I understand interactive compositions as musical works that involve mutual real-time adaptation between musicians who are usually playing an acoustic instrument and an interactive computer music system. And an interactive computer music system is a system that is capable of processing some sort of sensory information. In my pieces, that is almost always auditory information. It's sound, and it's capable of acting both in response to the musician's actions but also independently of them as a result of some autonomous algorithmic processes. So an interactive music system for me combines responsiveness with autonomy, with a certain degree of unpredictability.
Yeah. No, it's interesting that you talk of interactiveness as being something that's mutual, because often one thing that's come up in a lot of talks around the kind of FluCoMa technologies is that there's a difference between interactive and reactive systems. Yeah, perhaps to get into that, we could talk about some precise examples from your creative work. So to begin, perhaps your 2019 piece for piano and double bass, Converge and Diverge, gives a concrete example of one of these interactive music systems, or IMS, as you term them, in action. So perhaps just to begin, for those who aren't familiar with it, I wonder if you could quickly explain how the piece works.
Yes, it's really interesting that you're asking me about this piece in particular, because it's kind of an exception in my sort of list of works. So in the last years, I've really focused on music for one musician and computer and interactive music system. So this piece is obviously a piece for two musicians and computer, and this for me was a completely new and unique challenge. So I would say it's actually very different from the rest of my works. So in this piece, or I should say that this piece explores Sawyer's concept of collaborative emergence, which refers to the emergence of form in improvisational settings in which there is no structured plan or a leader, a conductor leading the improvisation. And it also explores the concept of joint agency. So in this piece, the musicians can initiate different interaction scenarios, different states of the interactive music system by playing timbrally similar and dissimilar sound material by converging or diverging. So the title of the piece, Converge, Diverge, really refers to a timbral spectral convergence and divergence. So the default state of the computer music system in this piece is called negotiate, and in this interaction scenario, the musicians interact with each other in a call and response fashion. They take turns playing sound material from a pool of partially notated musical actions. There are two additional pools of sound material for Converge and Diverge, and by playing sound material from one of these pools, a musician simply extends an invitation to their co-player to either converge or diverge. Now, what's interesting about this concept of invitation is that an invitation can be accepted or declined. So essentially, in order for any musical change to happen in this piece, the musicians have to act jointly. There are a couple of other interaction scenarios that are initiated only by the computer, but I think that the interesting aspect of this piece and what makes it different from the rest of my works is that the computer is not really responding to the musicians' individual actions. It's responding to the relation between their audio inputs. It's really responding to the interaction between the two musicians.
Yeah, no, it's really interesting. I mean, so this is the FluCoMa podcast, so we can get, without getting too technical, but we can talk about some of the sort of technological implementations of these ideas. Yeah, so I'm really interested in this idea of states that you talked about. So the system is in different states of convergence, divergence, negotiation, cooperation, to compete. So I wonder if it would be possible to kind of explain how you translate these ideas of a system's state using technology. So how do you go from this idea of a state to its material form? How and perhaps with some examples, how does this system in particular receive information? How does it assess, and how does it make decisions to impart agency?
So if I remember correctly, in this piece, the computer analyzes the two audio signals, the piano and double bass signal, and extracts some spectral descriptors. I believe that in this case it was MFCCs, but I am not entirely sure. And it then computes the Euclidean distance between the two audio inputs. The Euclidean distance is a distance metric, which essentially measures dissimilarity between two things. What's interesting about this piece is that the computer does not really have a preconception of convergence and divergence. It doesn't really know what convergence and divergence are supposed to sound like. So there aren't any hard-coded rules or any machine learning involved in identifying certain sonic interactions as convergent and others as divergent. The computer essentially calculates the Euclidean distance, this distance metric between the two audio inputs, and compares the current distance to previously observed values. So this also means that the computer in a way learns what timbral convergence and divergence sounds like during the performance. And an implication of this is also that at the beginning of the performance, the behavior of the computer music system can be a little bit unpredictable, a little bit unstable, and some of the ensembles that have performed this piece have actually decided to foreground that feature of the computer music system. I don't know if that answers the question regarding how these concepts are translated into sound. I could talk a little bit about one of these hidden interaction scenarios, one of these interaction scenarios that can only be initiated by the computer. This is called compete. And in this scenario, the computer only responds to one musician at a time, and specifically the musician who is currently playing the most novel sound material. And again, here the computer judges novelty by calculating the Euclidean distance between what the musician is currently playing and what they have played earlier in the performance. So yeah, I hope this gives a better idea of the piece and how these concepts are translated into sound interactions.
Yeah, no, it really does, and it's really interesting to hear about this conception of the emergence of, well, so the system being very or somewhat chaotic at the beginning and kind of going down through this from entropy towards this stable state, and to hear how you also describe the emergence of form through these interactions that are happening. And so, yeah, I wonder. So you say that some of the material's notated, but are different performances very different from each other? Or, I mean, how does it deploy itself over different occurrences? This piece.
They can be. So the material for some of the interaction scenarios is notated, but it is only partially notated. So this means that already certain aspects of the sound are left to the musicians. For some of the interaction scenarios, there isn't any sound material. Compete is one example where the musicians are just instructed to play novel sound material, to do things they haven't done so far in the performance. And then another factor that can be, another aspect that can be really different between different performances is form, obviously, because this is entirely left to the interaction between the musicians and the computer. So I did a comparative analysis of two different performances of the piece a few years ago, and I observed that the two ensembles had a very unique, a very different approach to form. So one of the ensembles, or in one of the performances, they were more clearly articulated, homogeneous musical sections, and in the other performance, you couldn't really establish sections. So it was more fluid. They were transitioning between different interaction scenarios more frequently, essentially.
Yeah. Something you talked about just now, so this idea of novelty and asking the players to propose things that are novel and that haven't been played yet. It brings me to another one of your pieces. So in 2020, a piece called Bias, which is another fascinating project. You called it a compositional experiment on the simulation of aesthetic judgments. But you also state that the system, the IMS, will only react to sounds it finds interesting. So I was wondering again if we could hear how you technically translate those ideas.
Certainly. So yeah, I guess this piece explores two things, and the one is computational aesthetic evaluation, and the other is AI or algorithmic bias, which consists in machine learning either making arbitrary false assumptions about data or amplifying bias that is already in the data. So this piece started with a little experiment. I invited clarinetist Szilard Benes to improvise and recorded some improvisations. I then segmented the audio recordings and evaluated small audio excerpts based on my subjective aesthetic preferences. So for the evaluation, I used a scale between 1 and 5, with 1 end corresponding to not at all interesting and the other to extremely interesting. So I used this labeled data as training examples for two separate neural networks, one performing an aesthetic evaluation on a sound event basis, on its individual sound event, and the other on longer segments of audio. So the basic idea behind this piece is that the computer music system performs an aesthetic evaluation of the musician's live audio input and imitates sounds it finds interesting, but remains silent or proposes new sound material when it loses interest in the musician's input. In this piece, the computer music system also collects its own sound material during different rehearsals and performances of the piece. And this is done by storing the spectral analysis of sounds the system finds interesting. And then using this spectral analysis to resynthesize the sounds during the current and future performances. An important implication of this is, of course, that the electronic sounds heard in the piece were not composed or even curated by me. So this is really meant as a component that allows a mediated dialogue between different performances, sort of co-creativity that is dispersed in time and space. What I should also mention about this piece is that this piece clearly takes a critical and subversive approach to machine learning. So the actual goal there was not to simulate my aesthetic judgments as accurately as possible. What I was far more interested in were all the different ways in which the machine learning algorithms would misinterpret and distort my aesthetic judgments. And the neural networks developed some interesting biases. So they did seem to prefer low frequency sounds over higher frequency sounds, and slowly evolving drone-like textures over virtuosic melodic passages. These are certainly plausible assumptions about my aesthetic preferences, but they're also a kind of oversimplified and exaggerated version of my aesthetic preferences. So yeah, it was very interesting to see how these biases developed by the neural networks affected the aesthetics of the piece. So the piece is really quite drony. It's much more drony than anything else that I have written. So the goal in this piece was really to use my own aesthetic agency as a starting point for the development of another aesthetic agency that is not really, that cannot entirely be traced back to my own aesthetic preferences.
Mm. Were there any occurrences of things that the machine would propose, sort of informing you that you must like this, you must find this interesting? Was there any example of maybe if it informed you a bit about your own ear, and you were surprised to hear those things?
Yeah, I can't say I was surprised, but yeah, I mean, kind of. I mean, it is true that I do prefer lower frequencies. So, if in a certain piece I can choose between a double bass and a violin, I would go for the double bass. But that was really interesting to see. Yeah.
Yeah. One, I think, quite interesting technical question from what you were saying about analysis windows. You talked at the beginning about evaluating the sound event and also a larger window. I was wondering if how another kind of geeky question, how you kind of define what a sound event is, and also during the live performance, how you dealt with analysis windows and time.
I am trying to remember. I don't want to say anything that is inaccurate, but I believe that for the sound event, I was really focusing on timbre, so it would just be something like MFCCs. And for musical phrases or textures, I looked at entirely different features. So I think that I worked with the density of musical events, something like inter-onset intervals. So it was really focused on texture analysis, on how many events are present within a certain window, what is the average inter-onset interval, and things like that. So it was really quite separate things, quite different features.
Yeah, okay. And one other thing I'd be interested to hear. So you talked about these machine learning AI system that gets trained and starts proposing things back to you. I was wondering so you said that the goal wasn't to create a perfect kind of training of an imprint of your musical ear, but I was wondering if you were content to stay with the first iteration of the training of the system, or did you go over do many different training sets and choose one that you preferred? How open were you to curating the trainings?
That's a very good question. I think that in this project in particular, I was happy with the first iteration. I wasn't really, I guess my interest wasn't really in optimization. So yeah, when I'm working with a different task, for instance, when it's really important for a certain piece that specific sound classes, specific types of sounds are classified with a certain accuracy, then I will definitely insist more on that. But in this particular project, I don't think it was so important. I'm still using normal machine learning practices. I'm still trying to train the neural networks. I still want the neural networks to learn something. But I guess that to a certain extent, what is good enough in a musical project is really an aesthetic decision rather than a technical decision.
Of course. So as we've heard, and as you've said, most of your pieces include human musicians who are playing acoustic instruments. And as you said, a core thread of your work is exploring that human-computer interactivity. So I'd love to hear about how you approach working with other musicians and your experiences bringing them into contact with these bespoke interactive music systems you make.
So I would say that I almost always work with musicians. I think I've done very few pieces that don't involve musicians. And I mean, I guess this starts from the concepts I'm working with. Because I am looking for interactivity, I'm looking for real-time interaction between the musicians and the computer. This essentially means that some decisions need to be left to the performer. So the performers need to make some choices during the performance, and they really need to be able to respond to the computer's current sound output. So this has really transformed the way I work with musicians. So I no longer write a fixed, thoroughly notated score presented to the musicians a few weeks before the performance. This is not my way of working. So musicians are usually involved very early on in the compositional process. This can take different forms. We can try some naive or informed rehearsals with the computer music system. So these are, for instance, improvisation sessions in which the musicians are not given any information regarding the system's interaction affordances prior to the improvisation. And so observing the musician's interaction with the computer music system really enables me to find the right instructions for them, to find these instructions that clearly delineate the piece aesthetically, but also leave a lot of space for the musicians to make their own decisions and to bring their own unique interpretive strategies into the piece. So yeah, these pieces are really co-authored with the musicians. In many senses, I consider myself the composer of these pieces, but not the single author of these pieces. So I guess in certain ways, the distribution of labor is very traditional. You know, I write the score, I write the code, they perform, but in many other ways it isn't, because the final product, so each performance is the product of a co-creative process between myself, the musicians, and the computer as well.
Yeah. Well, yeah, that was leading me on to my next question. You stated that much of your artistic research looks to explore these notions of authorship and performership and the construct of the musical work. One question around that I suppose arises is have these pieces, which, as you say, are co-authored with these musicians, have there been occurrences where they've been performed by other musicians, or are they something that necessarily need to be executed by these people that co-authored them?
No, actually, it's the opposite. So I really try to have these pieces performed by many musicians, and it doesn't mean that it is. Co-authorship can also be sort of distributed in time and space again. So I'm really interested in having this piece performed by different pieces and see their own individual approaches to these works. So these pieces really ask for interpretive individuality. It's an important part of the work. And so just to give a better example of this idea of distributed co-creativity, I could talk a little bit about the piece that I just finished working on. It's called Bias 2, and it's a piece for piano and interactive music system. And in this piece, a recurrent neural network, or RNN, actually tries to learn how performers navigate certain clusters of timbrally similar sounds, and proposes musical changes. It proposes sound material based on what it has learned from past performances. So in this piece, the musician is set in a dialogue with the work's interpretive history, with past interpretations of the piece. So this is really not a collaborative process between one composer and one performer or one ensemble. It's a much larger collaborative effort that is really dispersed in time, and space.
Mm. Yeah, it's really interesting. And so, yeah, so an important thing to understand when talking about co-authorship, also, at least in your perspective, is this idea of time, that it just, and that a piece's authorship doesn't necessarily just stop at one moment, and it can continue on. That's really interesting. Um, Concerning some of your academic writing, I had a question, because so I did my original studies in France, where the idea of practice-based research is still kind of getting going. So when I came to Huddersfield and to the UK, and saw all this great practice-led research, I was amazed by it. Um, and I'm really interested to hear about how you kind of work in that dynamic and balance. So you've characterized some of your pieces as compositional experiments. And I'm curious to hear about how you balance the different hats of artistic researcher, of composer, of creative coder, and to what extent do these activities merge, and generally how you balance creative and academic work.
Yeah, it's quite interesting that you mentioned that, because I actually did my doctoral studies in Austria, where artistic research is it's quite self-explanatory. You don't really have to explain what it is or why it needs to exist. But I also do realize that this is a concept that's, yeah, depending on the geographic location, people might understand or they might need more information on. So for me, actually, all these roles are one and the same. I have to code because my pieces make use of certain algorithms, whether these are machine learning algorithms or a very simple signal processing algorithm. So coding for me is very much a part of the compositional process. I would say that even data collection for machine learning is a compositional process. So there are so many aesthetic decisions involved in it that it also becomes part of the compositional process. And research and writing, in a way, is also part of the compositional process. So even though these two things are quite separate in time for me, so I usually start reflecting on the work I did and writing on a certain piece after it's done, after I'm finished. But still, this process of reflection is for me the bridge between the piece I've just completed and the next one. So it's really about understanding what this piece was about, which it's funny, but sometimes it is not entirely clear to me as I'm composing it. And yeah, it's about how reflecting on this work shapes my musical thinking and my future works.
Yeah, that's really interesting perspective, and it's of course probably symptomatic of my French upbringing, that I try to name those different roles and have those different actors. Where of course, why couldn't you occupy those things at the same time, and for them all to merge and to be as one? Yeah, that's really interesting. Um, Continuing about some of your research, I'm really interested to hear about a project you've recently joined. So I think you were saying earlier, you've been on it for about a year. Georgina Bourne's ERC-funded program, Music and Artificial Intelligence, Building Critical Interdisciplinary Studies. It sounds really fascinating. I was wondering if you could talk a bit about the project and some of the work that you're doing for it.
Definitely, yes. So obviously the MusAI project is a really large-scale research project, and it actually consists of several smaller projects or work packages, and each of these work packages focuses on different on a different field. For instance, there are certain work packages focusing on music recommendation systems, others focusing on commercial generative music. And my work is part of a sub-project called Algorithmic Composition Subverted. Actually, the entire title is Permeable Interdisciplinarity, Algorithmic Composition Subverted. And as part of this work package, Aaron Einbond and I are both working on musical pieces for acoustic instruments and electronics, and producing reflexive autoethnographies of working with AI as a creative tool. And among other things, we are investigating questions relating to distributed creativity, to musical authorship, data materialities, but viewed from the perspective of a composer and researcher.
That sounds great. And as with all of the things that we've been discussing today, we'll be linking to all those things down below, so people will be able to find them. I had a couple of perhaps broader questions I wanted to ask, finishing up. So you touched on it in the question before this one. I wanted to ask you about how you go about curating a corpus. So you were talking about data collection. Yeah, I'd like to hear more about that. It strikes me that each of your pieces seem to build upon a new corpus of sound each time. And I wondered, from what processes do your corpora emerge, and what role does a corpus of sound as an object play in your artistic project?
Well, it's really interesting because I guess corpus is not a word I use a lot, but I would have to say that there are different roles that this sort of music corpora play or sound corpora play in my pieces. So I talked earlier about Bias, the bass clarinet piece in which the interactive music system collects its own sound corpus. So in this particular case, I am really not curating the sound corpus, at least not directly. The neural networks are curating the sound corpus based on their sort of distorted version of my own aesthetic preferences. So in this particular piece, the corpus is assembled by all the musicians performing the piece. So when a musician performs this piece, they are both interacting with and contributing to this corpus. But I guess that there are other types of corpora in my works as well. So I talked before about the piano piece, in which past interpretations of the piece influence future performances. So these recordings of past performances of the piece are another sound corpus, and the training data extracted from these recordings. So these training data are also the crystallization of the performer's labor, in a way. And then there is another type of corpus, which are essentially these training examples that I collect to train simple classification algorithms. And what's interesting about them is how they foreground the materiality of data. So, for instance, if you want to train a machine learning algorithm to recognize 4 sound classes, 4 types of sounds, you generally have to record different versions of this sound. So you have to perhaps record them using different microphones if you don't want your machine learning algorithm to overfit the data and to learn something very specific to that microphone. You probably have to record these sounds in different dynamics, perhaps in different pitch ranges if that's possible or relevant. So this is another type of corpus that is invisible and inaudible in the pieces itself. It's just the data driving the machine learning models, but in some way it's a very important aspect of the piece, because it essentially determines how the interactive music system will behave in the performance, what kind of mistakes it will make, and so on.
Yeah. No, it's interesting to hear how they can have very functional roles and how you can go about collecting them in a very functional way to make something work in a certain way, and how it can also be a very aesthetic thing with much looser and fluid kind of boundaries. It's a really interesting concept, I think. So I wonder, maybe just to finish, so obviously we've been talking about this across the whole conversation, but maybe in a sort of broader sense. I'd be interested to hear about what it is that really draws you to using computational techniques such as machine learning and neural networks in your creative practice. What are the affordances, the limits? What is it about these technologies that draws you to them in an aesthetic sense? And also, how do you see your relationship with these technologies developing in the future with your future work?
That's a great question. So I guess that my relationship with these technologies has really evolved over the years. So initially I was really drawn to machine learning because I just wanted to explore the capabilities and the creative possibilities that I thought these algorithms opened. So at first I really used these algorithms in a rather conventional way in my pieces. But as I started using these algorithms, I became more and more interested in their specificities, in their limitations, in their materiality. So that's when I really started exploring aspects such as algorithmic bias in my pieces. Something else that I find fascinating about these algorithms is, well, not really the algorithms themselves, but the way they can challenge us to rethink musical authorship, the musical work. So the way that they challenge us, or the way that they shape and transform musical practices. So I guess that I'm really interested in this reciprocal relationship, again, between composition and technology. And the other side of this relationship is, of course, how artistic practice, how musical practice can really provide unique insights and perspectives into these algorithms, and specifically critical perspectives. I do think that the arts can provide some really, really unique insights into the materiality and limitations of machine learning algorithms. And unfortunately, the contribution of the artistic community to the discourse around AI and machine learning is still undervalued. And I think that's a pity.
Yeah, no, I couldn't agree more. And even though I'm optimistic that things seem to be getting better in that regard. Great. Well, Artemi, thank you so much. It was really, really interesting. So as I said, the everything that we've talked about will be listed below this video on the FluCoMa Learn platform, which is where it shall be living. And if people are watching this on YouTube, there'll be a little link in the description towards that page. So Artemi, thank you so much.
Thank you for the lovely discussion.
You're quite welcome. See you again soon.
Bye.